Hello everyone. For this tutorial video, I like to talk about how the chain rule works for multivariable functions, and how its formula is similar to differentials. If we remember what the chain rule was from Calc 1, the derivative of a function with another function as an input is the derivative of the input function times the derivative of the function with the input in it as normal. We can use a simpler notation for it. In particular, if we state that x is a function of t and y is a function of x as usual, then the change of y with respect to change in t equals the change in y over the change in x times the change in x over the change in t. So if we are asked to find the derivative of z with respect to t, where z is a function of x and x and y are two separate functions of t, we do this by partial derivative with respect to x times change in x over change in t plus partial derivative with respect to y times change of y with respect to change in t. And this is our final answer for the change in the overall function with respect to t. We can get a more general form for the chain rule by doing z is a function of n variables x sub 1, x sub 2, x sub 3, etc. and that each of these x's is a function of m variables, m sub 1, m sub 2, and sub 3, etc. Then it follows that for any one individual variable, the change in z with respect to this variable is the change in z with respect to change of x1 times the change of x1 with respect to the change of m1, plus this again, but we use x2 instead of x1, and we keep reiterating the process for as many x's as there are. And this may seem a lot to handle at first, but if we consult a diagram, we see why the formula works the way it does. In particular, if x and y are functions of other variables, the first order derivative of z would be these two derivatives first, so the derivative with respect to x and the derivative with respect to y. But then we see it branches out, so the derivative of x and y again with respect to their inputs. And if these in turn are functions of something else, we get another branch of the tree with even more outputs. Now that we've explained how the chain rule works, we can talk about the most sophisticated but the most accurate type of 3D derivative, which is called the directional derivative, and refers to the rate of change in a specific direction given by a vector, instead of the rate of change related to one variable. So the directional derivative allows us to take the derivative in more directions than simply straight along one input at a time. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.